Assalamualaikum warahmatullahi wabarakatuh. Di sini kami akan mempresentasikan hasil kerja kami, yaitu penerapan metodologi riset operasi yang terintegrasi dalam ekspansi kendaraan listrik. Saya sendiri dengan Fernando Ramadhani dengan NPM 23170510660
Saya
dan
sendiri sini
rekan saya.
Muhammad Ilham Akbar dengan NPM 235705909.
Oke, jadi di sini langsung saja kita ke latar belakang dan rumusan masalah. Jadi pertama-tama, transisi global menuju energi berkelanjutan saat ini mendorong adopsi kendaraan listrik secara masif di kawasan Asia Tenggara. Indonesia di sini berada di posisi yang sangat strategis karena kita memiliki cadangan nikel terbesar yang ada di dunia, bahan baku utama dari baterai kendaraan listrik itu sendiri. Sehingga Indonesia bukan hanya menjadi pasar, tetapi juga calon hub rantai pasok baterai kendaraan listrik global. Data juga mendukung tren ini. Berdasarkan Gaikindo 2025, penjualan kendaraan listrik berbasis baterai atau BEV secara nasional itu tumbuh sebesar 141% secara tahun ke tahun, dengan total penjualan melampaui 103.000 unit. Tapi di balik peluang besar ini, Finfast menghadapi 4 persoalan strategis yang krusial yang menjadi fokus kajian utama kami. Yaitu yang pertama, penentuan lokasi pabrik yang optimal berdasarkan banyak kriteria yang saling bertentangan. Yang kedua, ada penentuan kapasitas produksi awal di tengah resiko fluktuasi dan permintaan pasar. Ketiga, ada pemilihan teknologi baterai di bawah kondisi ketidakpastian yang ekstrim. Dan keempat, ada strategi kompetitif yang optimal dalam menghadapi manuver agresif dari perusahaan BYD, yaitu kompetitor utama dari perusahaan Finfast ini. Lalu keempat persoalan inilah yang akan kami jawab satu persatu menggunakan metodologi operasi riset yang berbeda-beda. Lalu selanjutnya ada kami memetakan 4 rumusan masalah tadi ke 4 metodologi riset operasi yang sesuai. Yang pertama, untuk menyelesaikan masalah lokasi pabrik ini, kami menggunakan analitik hierarki proses atau yang biasa disebut AHP. Ini cocok karena masalahnya itu bersifat multi kriteria yang saling berkonflik. Itu biaya, logistik, SDM, insentif, sehingga perlu didekomposisi menjadi bobot matematis yang konsisten. Lalu yang kedua, ada kapasitas produksi, yaitu kami menggunakan decision analisis dipadukan dengan teorema bias. Di sini resikonya sudah bisa dikuantifikasi melalui probabilitas. Jadi kami hitung IMP-nya, lalu kami perbarui probabilitas tersebut begitu ada sinyal informasi baru dari pasar. Lalu yang ketiga, untuk teknologi baterai, yaitu kami menggunakan kriteria ketidakpastian, yaitu maksimin, maximas, Hurwitz, dan minimax regret. Di sini kami pilih ini karena untuk skenario masa depan teknologi baterai, probabilitasnya itu belum bisa diestimasikan sama sekali. Lalu yang keempat, ada strategi untuk menghadapi perusahaan BYD. Kami menggunakan game teori, khususnya Nash Equilibrium, karena ini adalah interaksi strategis dua pemain yang rasional dan saling bergantung satu sama lain. Lalu selanjutnya, pada analisis AHP ini, dari hasil pembobotan AHP, kriteria yang paling dominan itu adalah C1, yaitu biaya lahan dan konstruksi, dengan bobotnya yaitu 47,6%, disusul oleh C4, intensi pemerintah daerah sebesar 26,8%, sementara aksesibilitas logistik berada di 17,6% dan tenaga kerja terampil berada di paling akhir yaitu 8%. Nah, yang penting untuk digarisbawahi, nilai konsistensi rasio atau CR kami ini adalah 0,022, jauh di bawah ambang batas yaitu 0,10, yang artinya penilaian perbandingan berpasangan yang kami lakukan ini konsisten secara matematis dan bisa dipercaya. Lalu setelah skor-skor kriteria ini kami kalikan dengan skor masing-masing alternatif lokasi, hasilnya menunjukkan Subang sebagai rekomendasi terbaik dengan skor global yaitu 0,4656. Subang di sini unggul karena performanya kuat di dua kriteria dengan bobot tertinggi yaitu C1 dan C4 yang totalnya mencapai 74,4% dari keseluruhan bobot. Nah, di sini hasil model kami ini konsisten dengan keputusan aktual Finfast di dunia nyata yang memang telah merealisasikan pabriknya di Subang, yaitu dengan luas tanahnya sekitar 171 hektar. Investasi investasi 300 juta US dollar dengan kapasitas awalnya 50.000 unit per tahun. Ini menunjukkan bahwa pendekatan AHP kami valid untuk merepresentasikan logika pengambilan keputusan strategis semacam ini. Lalu di sini kami mengevaluasi 3 alternatif kapasitas produksi, yaitu 15.000, 30.000, dan 50.000 unit per tahun. Dengan mempertimbangkan 3 kondisi pasar yang mungkin terjadi. Probabilitas awal atau prior yang kami gunakan adalah kondisi tingginya itu 35%, sedangnya 45%, dan rendahnya 20%. Probabilitas ini kami susun berdasarkan tren pertumbuhan pasar EV yang sudah kita bahas di slide sebelumnya. Dari matriks payoff dalam satuan miliar rupiah setelah dihitung EMV-nya atau expected monetary value-nya untuk masing-masing alternatif, hasilnya yaitu alternatif A1 dengan 15.000 unit menghasilkan EMV 165,25 miliar. A2 dengan 30.000 unit menghasilkan 216,50 miliar yang tertinggi, dan A3 dengan 50.000 unit menghasilkan 215,50 miliar. Jadi berdasarkan priornya saja, A2 yaitu kapasitas 30.000 unit ini adalah pilihan yang paling optimal. Namun dengan catatan selisih EMV antara A2 dan A3 ini hanya 1 miliar rupiah saja. Itu sangat tipis, yang artinya keputusan ini sangat sensitif terhadap perubahan probabilitas. Karena keputusannya setipis itu, sinyal pasar baru menjadi sangat krusial untuk dipertimbangkan. Dan itu yang akan kita bahas di slide selanjutnya, yaitu teorema Bayes. Nah, setelah mendapatkan prior tadi, kami masukkan sinyal permintaan kuat yang muncul dari data pasar terbaru. Lalu memperbarui probabilitasnya menggunakan teorema Bayes. Kondisi tinggi yang awalnya priornya 35% dikalikan likelihood 0,880 menghasilkan posterior yaitu 52,34%, naik signifikan. Kondisi sedang dari prior 45 dengan likelihoodnya 0,50, posteriornya menjadi 42,06. Sementara kondisi rendah dari 20% dengan likelihoodnya hanya 0,15, posteriornya turun drastis menjadi 5,61%. Dengan probabilitas baru ini kami menghitung ulang EMV-nya dan terjadi sesuatu yang menarik, yaitu decision reversal atau pembalikan keputusan. Yang tadinya A2 itu optimal berdasarkan prior, sekarang A3 kapasitas penuh yaitu 50.000 unit menjadi optimal dengan EMV sekitar 264,53 miliar rupiah atau unggul 25,56 miliar dibanding A2. Yang membuat temuan ini semakin kuat, kami mengonfirmasi dengan data real penjualan wholesale VinFast pada Desember 2025 itu melonjak hingga sekitar 7.800 unit, bahkan melampaui BYD pada bulan tersebut menurut databook 2026. Ini konsisten dengan sinyal permintaan kuat yang kami modelkan secara Bayesian. Selanjutnya bisa dilanjutkan oleh rekan saya.
Okay, untuk slide number 7 is battery technology selection. And I'm going to explain in English terms because Nanda already explained in Indonesia. So, on this analysis, selecting the optimal battery technology for VinFast vehicle platform in Indonesia is one of the problems is fundamentally different character from the previous one. Unlike the production capacity decision, where we could estimate market probability from historical, the future dominance of battery technology is genuinely unknown because we cannot assign meaningful probability to which technology will win the market from 5 years from now. This is classic decision under uncertainty. And that's precisely why we apply for uncertainty criteria here: Maximin, Maximex, Hurwich, and Minimax trigger. We evaluated 3 technology alternatives. One is LFP, lithium ferrophosphate, a mature technology with lower cost and strong safety profile, but limited energy density. The B2 is NMC, is nickel, manganese, cobalt, which is the balanced energy density and also the cost and community used in mid-range EVs. The B3 is solid-state battery. The next generation of technology is promising, but dramatically higher energy density and faster charging, but well, not yet commercially mature at competitive cost. The total battery is a benefit index from 0 to 100, reflecting the combined sustainability of cost structure, energy competitiveness, and absolute sense risk for each combination. Looking at the result on the table as we see, the maximum criteria, the criterion which is takes more conservative pessimistic stance, selected NMC B2, because its worst case score of 50 is the highest among all alternatives. The Maximex criterion, the most optimistic view, selected solid state, or we can say it's B3, with a peak score of 95 in the breakthrough scenario. The Hurwich criterion, which with a natural coefficient of 0.5 also selected P3 with combined index of 67.5. Now, the minimax criteria regression, it is developed by Savage, Measure Opportunity Loss. This we ask, if a scanner actually occurs and we make the wrong choice, how much will we regret it? Look at the regret matrix right here. The LFE carries the maximum regret of 60 if the solid state breakthrough happens. NFC carries 45, solid state surprisingly carries only a maximum regret of 38. From scenario S1, so minimax regret also points to a solid state P3. 3 out of 4 criteria consistently recommend solid state. But however, our recommendation for the short to medium term is NMC or P2 because the FinFET is the in-early penetration phase where operational stability and the cost certainly matter more than chasing unproven technology. And that's why in maximum criterion is the most appropriate when the downside risk of a wrong bet on immature technology is simply too large to absorb. That said, 3 criteria clearly signal the long-run potential of solid state. So we also recommend allocating a portion of R&D research to the monitor to monitor its commercial red lines because ensuring FinFET doesn't miss the window if that breakthrough arrives. Slide number 8, the game theory. FinFET versus BYD with using payoff matrix. And the fourth analysis and final analysis addresses perhaps the most strategically critical question. How should FinFET compare against BYD? This problem is structurally different from everything before it, because the FinFET outcomes are no longer determined solely by its own decision, but they depend on how rational, autonomous competitor responds. This interdependence is exactly what game theory is designed to model, because drawing on the foundational work of von Neumann and Morgenstern. To set the context, as 2025, BYD holds approximately 45% of the Indonesian national BEV market share, which is while the FinFET has grown around 10.5%. Notably, in December 2025, FinFET monthly sales actually exceeded BYD for the first time, a signal of the competitive momentum. We define 3 strategies for each player. For the FinFET, V1, an aggressive price war to capture market share. The V2, service differentiation, leveraging battery subscription program, and strong after-sales warranties. And the last is V3, is a niche focus on fleet and commercial vehicle, capitalizing an ecosystem like Shan SM and the Go Green SM partnership with Gojek. For BYD, B1, the maintaining its lower price strategy. B2 is expanding the model from some lineups across the segment, and the last is B3 is strengthening its after-sales network. The payoff metric is exposed that in the percentage points of the market share gain loss for FinFET in zero-sum priming against BYD. The critical finding here is immediately visible. V1, the price war, is dominated strategy. Every entry in the world V1 is strictly lower than corresponding entry in V2 and V3, regardless of what BYD does. FinFET always perform worse when it chooses a price war, because this is not a coincidence, because it reflects a structural reality. Because the BYD Subang plant has a capacity of 150,000 units per year, 3 times more than FinFET has one capacity of 50,000 units, while BYD has massive economies of scale advantage in the price war. Engaging on that battlefield is irrational for FinFET, of course, because the BYD is more bigger. And having eliminated P1, while we eliminated the P1 things, the matrix reduced to 2 multiply 3 games involving B2 and B3. We then check for BYD dominated strategies and find that B3 is dominated by B2 for BYD's perspective. Since BYD wants to minimize the first payoff by eliminating B3, leaves us with a clean 2 multiply 2 matrix, and that's what we solve for the next slide. Next slide. And it is a Nash equilibrium strategic implication. With our reduced 2 multiply 2 matrix containing strategy V2 and V3 for the FinFET and B2 and B1 and B2 for BYD, we now solve for the Nash equilibrium. First, we check for the sample point is in pure strategic, because the maximum value for FinFET through this of the worst outcomes is 1. The minimum value for BYD, the smallest of the column maximums, is 2. Since 1 doesn't not equal 2, there's no saddle point. This means no single pure strategy pairs forms a stable equilibrium. Both pairs need to mix their strategies, which is precisely what Nash theorem guarantees. Which is precisely what Nash theorem guaranteed force solution for. To find the mixed strategies for Nash equilibrium, we solve for the probability at a FinFET is indifferent between V2 and V3, and Q at which BYD is indifferent between B1 and B2. Substituting the payoff value into the standard formula, we get P equals 1/3, meaning FinFET should play V2 surface differentiation with a probability of 1/3, or roughly 33%, and V3, the flip niche focus, with a probability of 2/3 or 67% for BYD. Key also equals 1/3 for B1 and 2/3 for B2. The value of the game, I mean the FinFast expected market share gain at equilibrium is 5 divided by 3, and unfortunately it's plus 1.67 percentage point. This is positive number for the FinFast, meaning that even against dominant competitor, a rational equilibrium still deliver FinFast in net gain in market position. But what does this mean in practice? The two-third weight on the fleet and the commercial niche strategy is not arbitrary. It's mathematically derived, and it's consistent with that FinFast is actually doing is expanding Shan SM taxi operation, depending to the Go Green. SM partnership with the Gojek across city like Makassar, Bekasi, and Surabaya. This moves to build a captive market largely insulated from direct BYD competitor. In summary, avoid price wars, commit to service, differentiation, and concentrate competitive resource on the commercial fleet segment where BYD has not intensively penetrated. And next slide. The bringing together for all analysis, we arrive at a coherent, mathematically grounded strategic framework for the FinFast Indonesia expansion. The AP analysis constantly recommends Subang as an optional factorial equation with global score of 0.4656, significantly ahead of the Bekasi at 0.2968 and Karawang at 0.2376. The Bayesian modification analysis reveals a critical decision reversal based on prior probabilities alone. The 30,000 unit capacity appeared optimal, but after updating probabilities in response to a strong demand signal, reflecting the kind of the market indicator that mirrored FinFast, actual in December 2025 sales surge, the full 50,000 unit capacity at Subang becomes the rational choice with a posterior EMV of 264.53 billion rupiah. The uncertainty analysis recommends NMC technologies for the near term, based on the maximum criterion appropriate for early stage investment decision with high downside risk. And last one, in the game theory analysis concluded price war frame is a mathematically irrational for FinFast, and the Nash equilibrium mixed strategy to third fleet niche, 1/3 surface differentiation produce the game value of plus 1.67 market share points for the FinFast at equilibrium. And because of that, these four results are not independent recommendation stacked on top of each other because they are from integrated chain. The Subang location enables full capacity production. The NMC technology provides cost-effective vehicle for the fleet segment identically, and by game theory, the competitive strategies avoid the price war that FinFast current scale cannot win. Next slide. And this slide, we want to be transparent about our limitation for this study before concluding. Because first, all the data used in this paper comes from secondary source and official reports from Gaikindo, FinFast Press release, BKPM publication, and industry coverage. And this quantity of payoff values in our metrics are research constructed, estimated based on the comparative reasoning. This is not proprietary mixed with internal from the FinFast because it's just a secondary data. This is an inherent constraint of academic research on corporate strategy. And second is the AIP weight and Bayesian probability. Contains subjective elements because even though we validated them with the consistency ratio and explicit qualitative justification, different research might arrive at different weights. And the third is a single instrumental case study. So the framework should not apply mathematically. This should not apply technically to other EV manufacturer without adaptation. Then the last one is on the fourth. The EV market in Indonesia is moving extremely fast, so fast that policies change around intensive domestic content requirement and battery technology breakthrough could shift our model parameters significantly beyond 2024 until 2026. And for the recommendation from us is for future research, strengthen the model with primary data through the interview with FinFast management or industry stakeholders, maybe like the president or the CEO itself, conduct sensitivity analysis on the AHP weight and the payoff values to test the robustness of our conclusion, and extend the methodology with linear programming for supply chain and optimization or Monte Carlo simulation for research probabilities model. And next one. Well, that is the closing for us. To conclude our presentation on the application of integrated operation and research methodologies to FinFast electric vehicle expansion strategies in Indonesia. To summarize in one sentence, produce at full capacity in Subang, deploy NMC technology as near-term foundation, avoid direct price competing with BYD, and concentrate competitive energy on the fleet and commercial segment. This is the cohesive, quantitatively grounded strategies, while the framework of our four analysis could range on. We are now open for question and discussion for something in the comment section. And thank you very much for this attention while our team presentation. I'm sorry if there's many words that maybe really have bad spelling or something. For myself, I feel very sorry. And I also, representative of my friend is Nando, saying thank you very much for the attention. And we end the presentation now. Thank you very much. And we end. Wassalamualaikum warahmatullahi wabarakatuh.